EG 121 Transport Engineering and Surveying, Video Lecture 7A, Setting Out Principles. Good, so we're moving on now from rather than just looking at measuring what's there, working out positions of control points, measuring the level of the ground. We're now moving on to actually setting out buildings, setting out roads, setting out the structures. So this is a little introductory lecture to get you through what the principles are, what the main techniques are. You will have seen this, if you've been watching, and I hope you have, the construction of the new residences on the Swansea side of the Bay campus. Now, for months now, they have been setting out the foundations of the new building, and you will have seen those staked out, marked out, then excavated, and now they're currently filling in the strip foundations for the walls. Now, all of that happens because we set out those locations very, very clearly so that people know where to dig and everyone knows where the structures are going to go. And that's all that setting out is the staking out of these reference points, so staking out where the road's going to go, where the building's going to go, where the different components, the different elements of construction are going to go. This is a picture of an excavated trench. You can see here you've got, let's just pick up the highlighter. You can see here we've got these rails and these strings that are suspended above the trench. So that is what is guiding the excavation of this trench. The edges of the excavation are marked out using strings in this case, which are supported by these wooden rails, and therefore the workers know where to dig. Another picture here, this is for the side of a roadway. It's just been marked out with paint in this case. Okay, principles of setting out. Control points are important. Now with the traverse exercise, what you were doing was setting out control points. You were setting out locations where we knew the x coordinate and the y coordinate. If we had done a levelling exercise as well from a known point, we could also work out the vertical point, and that would have given us a horizontal and vertical control point. Now, any construction site needs a number of these control points because this is how we find our reference point for us to set out the buildings, to set out the road, which is why it's important that we did the control survey with you and we took you through that process, because without a control survey to give you some control points, you can't then take it to the next stage and do any setting out because you don't have enough locations that are known. So with setting out, those control points should be located so that the design points, and the design points are the locations of the buildings, of the structure of the road, there should be enough of them on the site for you to be able to use 2 or 3 control points to identify the location of one design point. So there's a little bit of redundancy and a little bit of checking in there. Protection of those control points is important. We haven't done this because we're not doing the full exercise, but if you're on site, those control stations that you've set up would normally be set in concrete and they'd be protected by guardrails so that there were no knocks, no taps. As you know, we can get to millimetre accuracy, so those control points have to not be trodden on. They can't be knocked by machinery. Otherwise, what's the point? You've lost your reference point and it's moved. So they would normally be guarded. So have a look out for some of those on the site next door. Now there's 2 ways of setting out that I'm going to cover very, very quickly here. One is the use of a baseline. The other is setting out of circular curves. But a baseline is just a line running between 2 points of known position, so 2 control points. 2 control points, you draw a line between them, that becomes your baseline, and then that becomes somewhere where you can carry on setting out the building or the road as you need it. The other method is to set out curve features, so circular curve, and for this you use the geometry of a circle to place intersection points, tangent points, and the intermediate points in the curve so that you can see, actually physically see, the route that the curve is going to take and the road curve is going to go. So there are three methods that we look at for baseline setting out. They're all pretty straightforward because it's just linear and angular geometry here. So in the first one is offsetting. In this case, you've got your baseline running from A to B. You know that you want to set up a point D. What you need for that is the distance from one of those control points along the baseline, and then the offset distance, the perpendicular offset distance from that baseline. So all you're really given, as long as you've got the baseline, you just need those two dimensions, the distance from a control point and the offset distance from the baseline itself. And that allows you to identify the location of that design point. In this case, it's the corner of the proposed building, but it might be the edge of a carriageway. Another way is to use combinations of angles and distances to place points of the building. In this case, you've got a primary site control at E and a primary site control at F, and we have a baseline from E to F. What we then do is set up secondary site controls, which are created purely for setting out this building at A and B. And we've got a baseline running from A and B. We can set the position of A and B because you know the distances and the angles as we look to them, so we can use geometry to do that. And then we've got offset distances from A and from B to the building itself. The third method is using known distances. In this case, we've got our control points here and here where the little triangles are. We just need to know the distances from each control point to the design points. And as long as we've got the distances from two control points, we don't need any other angles, we can always find that location. So baseline, as you can tell, as long as you've got a good sense of spatial awareness and you can understand basic geometry, setting out of structures from baselines is fairly trivial, it's fairly straightforward. Horizontal curves are only a little bit more tricky because you have to understand circular geometry, which normally people need reminding of. Horizontal curves used extensively in roads and railways to connect straight sections because we can't have very sharp corners on high-speed roads, that is a hazard. We look at circular curves and transition curves. So with circular horizontal curves, we look at three main types. We've got simple circular curves where you've got a constant radius. A compound circular curve would be one where you have 2 points of origin. So in this case, we have the first part of the curve with a large curvature, and the second part of the curve with a smaller curvature. We've also got reverse circular curves, and in this case you can see, moving off this tangent point circular curve, we have a tangent line here and a second circular curve with a different radius moving off. And that's connecting this road and connecting this road. So let's look at a curve. We have a road coming up here towards T. We've got a road going away from point U. We need to connect them with a circular curve. Now what I'm going to just do is redraw another version of this because it's easy to see if you've got a different intersection angle. So let's say what I'm going to do is just redraw this slightly. Let's say we have a road coming in like this and a road coming in like this. So we've got a much smaller intersection angle. Now the curve that would join that would be something like this. The origin would be somewhere down here. That would give us the intersection angle between them, so we're going from T to U. The straight line distance TU would be that. We've got a right angle there, we've got a right angle there. And of course we've got right angles in the middle here. The only reason I'm redrawing it is because this is slightly misleading in that the intersection angle is about 90 degrees. But you wouldn't have it entirely symmetrical as it appears to be in this. It would normally be more offset like this. So points to note, intersection point is where those two tangents meet. Tangent points are where the curve first deviates from that tangent line. The tangent lengths are the distance from those tangent points to the intersection point. P is the midpoint of the curve. TSU is the chord from the first tangent point to the second tangent point, and S is the midpoint of that. Theta is a deflection angle, which is also equal to this angle in here. R is the radius of curvature, and O is the centre of curvature. So we're going to use that now. Okay, horizontal curves. So we can work out the straight distance from the first and second tangent point using geometry. So what we're interested in is, let's move it to red, is this distance here from T1 to T2. That's going to be our straight line distance. Now, how can we do that? Well, let's look at this little triangle in here. We know that we've got a right angle here. We want to work out, let's say, this is half the distance we're interested in, so let's calculate that. We've got an angle and we've got the hypotenuse. So sine of theta over 2 is going to be equal to half of T1, T2 divided by R. Rearrange that. T1, T2 is equal to 2R sine theta over 2. Job done. Okay, second one. Want to work out the straight distance from the first tangent point to the intersection point. This is what the L is here, so we're trying to work out what this L distance is. Okay, similar thing. Let's look at this triangle. Now we know that here we have a right angle. We've also got this internal angle here. And we've got R, we want to find L. Now in this case we've got opposite adjacent, we can use tan. So in this case tan theta over 2 is equal to L over R. We also rewrite L as T1I because that's what it is. So T1I is equal to R tan theta over 2. And finally, the circular distance from the first to second tangent point. So what we're interested in is the length of this curve, and this is useful because you want to know the total distance of the curve. For example, for curbstones, you need to be able to calculate how many curbstones you need to cover that distance, and also what the change is going to be of the road itself. So to work out this, we can just use a ratio method. So this distance, T1, T2 arc, divided by the intersection angle, or the angle between those two tangent points. The ratio of these two is going to be the same as the circumference of the whole circle divided by 360. So those have to be equal to each other. So this expression for the circumference is 2 pi r. Rearrange that. We've got circular distance from the first to second tangent point is equal to intersection angle multiplied by the radius by pi over 180. So what we can do now is apply this to a horizontal curve example. In this case, we've got a road. What we want to do is change this one-way road into a two-way road. To do that, we need to remove these sharp corners here and here. We want to bring back this slope. We want to curve back this so that all of this area is then free for traffic to move in. The final curve layout is going to be more like this. And all of this needs to be removed, all of this needs to be removed. Okay, so how would you do it? Think about how you're going to locate the start of the new curves. How could you work out the length of the new curves? If curbstones are 300 mm long, how many do you need for the new curves that are going to be built? So I'll start you off because I can show you the tangent points. The first one is here. This is our first tangent point. This is our second tangent point. Theta 1, theta 2. Now curve 1 is going to have, this is curve 1, this is curve 2. So curve 1 is going to have a radius of 15 meters and a deflection angle of 36. So that's equal to 36. And curve 2 is going to have a radius of 30 meters and a deflection angle of 58. That's enough information. All you need are these three equations. Have a think, have a go, and we'll go over the solution in the lecture.